All right, so now we're in section 2.8, the last section of chapter 2, and it involves solving linear inequalities. So earlier in the chapter, we were solving equations, right? So an equation means an equal sign is present, right? An equal sign. So with inequalities, inequalities have inequality symbols. So we have a less than, you could have a greater than, you have a less than or equal to, and you have a greater than or equal to. So those are all of your options for inequality symbols, right? So your less than, your greater than, the less than or equal to. So remember there's half an equal sign present. And then greater than or equal to, there's a half an equal sign present. Okay? So those are your symbols. You read from left to right. So if the mouth is not open to the left, it's a less than. So you want to make sure you can read it. So we want to understand that in the previous chapter, we were solving. So x equals to 3. Well, what does that mean? That means that to make the statement true, x would have to be equal to 3, right? So x is always just 3 for this particular statement here, right? So when we're looking at inequalities, 3 would just be 3. So x would just be equal to 3. When we're looking at inequalities, however, our unknown or our variable could represent more than just one value, possibly, right? So this says x must be less than 3, or x is less than 3. So the solution to this inequality solution is any number that is what? Less than 3. So when we do inequalities, we solve inequalities. Then you have to graph the inequality solution. And then you have to write the solution in interval notation. So solving, we know how to solve. We learned how to solve earlier in the chapter. It just means the variable should be isolated on one side of the symbol, of the inequality symbol. Okay, so this problem is what? Solved, right? Yes. Then it says you graph the solution. So we want to understand what is the solution here. So unlike the equal sign, x is not just equal to 3. Here, x must be any number less than 3. So that means what? 2, 1, 0, -1, -2, -3. But there's so many numbers that are less than 3. So we graph the solution so we can get a visual of the solution. So a less than. So when you're doing your graphing, when your inequality symbol is a less than, we are going to use what we know of as parentheses. So some people use open or closed circles. But when you're doing less thans, you're going to do parentheses. All right, parentheses. So a parenthesis at 3, and the values that are solutions to this are all the numbers that are less than 3. So you just shade, it's like a shade. You shade or draw an arrow to everything that's less than 3. So remember the arrows. This is what? The real number line. So the real number line goes from a negative infinity to a positive infinity, with 0 separating the negative from the positive, right? Remember your real number line, okay? All right, so here is my graph to my solution. So we have the solution. Then we have a visual of it. And then the third step says interval notation. So what is the interval notation? Well, the interval notation is when we are writing the solution in a nice little interval. And in an interval, you're going to have your smallest value to your largest value. And we're just saying parentheses, but it can be interchanged, right, to parentheses or brackets when we get to that. So from the left, the smallest value that is a solution to this inequality is what? Negative infinity. Because negative infinity is less than 3. And what is the largest value that is present here? It goes up to 3 with a parenthesis. So you have a solution, you have a graph, and you have interval notation. So the solution, the visual of the solution, and then the interval of the solution. Okay? All right. So if we have x is greater than 3, so again, we have our solution already because it's solved. The variable is isolated on one side of the inequality symbol. Next, we would have to graph the solution. So the graph here, I draw the number line. Everything's graphed on the number line. I identify where 3 is located. And now I'm going to use a parenthesis. The x must be greater than 3. So wherever my solution is, my solution would be the numbers that are greater than 3. So my solution is what? To the right. And on the 3, we would put a parenthesis because there is no or equal to. So what would be the interval notation here? Again, we're reading from left to right because it's the smallest value to the largest value. So the smallest value would be at 3 with a parenthesis on it. And then it's going out to positive infinity, which makes sense. Any number that is bigger than 3 is a solution. 45, 100, 3,000, 5,000, 20,000, 100,000, a million. All of those are solutions because they are greater than 3. Right? On this one, x is less than 3, negative 50. Negative 1,000, negative 1,000,000, negative 20 million. All of those are solutions because they are less than 3. Okay? Now, on your infinities, you should always use parentheses on the infinities. So when you're doing it, the infinity symbol is always a parenthesis. Always parentheses. Infinities always use parentheses because you can't actually count a infinity. So you can never use a bracket on an infinity. We haven't used brackets yet, but I'm about to do next. All right? Okay. So let's say we have x is less than or equal to negative 3. So we graph our solution. So x is less than or equal to negative 3. So less than lets me know I'm going to the left because that's where the numbers are smaller than negative 3. The less than or equal to, the or equal to lets you know that you must use brackets. You must use brackets. So there's a bracket at the negative 3. So what does that mean? It means that negative 3 is part of the solution because it says the x can be less than or equal to negative 3. So negative 3 is a part of the solution because the x could be equal to negative 3. So what would be the interval notation here? Well, from left to right, the smallest value is negative infinity and the largest value is negative 3 with a bracket on it. All right. So then x is greater than or equal to negative 3. So that's solved already, right? Because the x is isolated. So then I'm going to mark my 0 and mark my value. So I'm at negative 3. It says that the x is greater than or equal to negative 3. So I know it's a bracket and it's open to the right because that's where the numbers are what? Greater than negative 3. So my interval notation here would be from the left. First thing I see is a bracket at negative 3, and my arrow tells me that we go to positive infinity. So when you're solving your linear inequalities, you have to solve, you have to graph the solution, and then you have to write the solution in interval notation. All right? So if there is no or equal to, you're going to use parentheses. If there's or equal to's, you use in brackets. But remember, the infinity symbols always have a parenthesis on them, no matter what, right? You cannot put a bracket on an infinity because you can't actually touch infinity. It's not tangible. So brackets is for those that are included, that values that you can touch and that are tangible. All right? Okay, let's do some problems. All right, so here we're solving some linear inequalities. We have some examples here. X is less than or equal to -1. So all of these examples here are solved already, right? So we don't have to solve. We're just practicing being able to graph and do interval notation first. So X is less than or equal to 1. So it's already solved because my variable is isolated on one side of the inequality symbol. So I know it's solved. So I just have to graph it. So I identify my number line. I mark my -1. It's a less than or equal to. So I know I have a bracket because of the or equal to. Where are the values less than? They will go to the left. So I would have a bracket on my -1. So my interval notation would be -infinity to -1 with a bracket. All right. X is greater than 1/2. So again, it's already solved. I mark my 0. I mark my 1/2. And remember, if you have numbers, 1/2 would be what? Less than 1, right? So just make sure you understand. You can't put 1 and then put 1/2 after 1. That would be incorrect. So X is, that's why I just mark your 0 and then just mark your value. X is greater than 1/2. So greater than means we're going to the right. And it's a parenthesis because there's no or equal to. So our interval notation would be parenthesis 1/2 to infinity. All right, then we have y is greater than or equal to 5. Y is less than 0. So, of course, I think you should pause it and try to do those two by yourself. Right, and then unpause it and see if you got them correct. So, y is greater than or equal to 5. So, I mark my 5. Y is greater than or equal to, so it's a bracket, it's greater than, so it's opening to the right side because that's where the values are greater than 5. So my interval notation would be from 5 to infinity. Then we have y is less than 0. So we mark 0. Where are the values less than 0? To the left. To the left. So I put a parenthesis. And so I have from -infinity to 0 in parentheses. Okay, so solving linear inequalities. So you solve, you graph, you write the solution in interval notation. All right, so these all just happen to be solved already, but you still have to graph it and do the interval notation for it. All right, so let's do some where we actually have to solve for the variable first. All right, so here we have x minus 2 is greater than or equal to -7. X plus 4 is less than or equal to 1. So here we go, x minus 2 is greater than or equal to -7. So remember, we're solving, right? So when you solve, you have to solve. Then you have to what? Graph. Then you have to write the solution in interval notation. So x minus 2 is greater than or equal to -7. So we have to solve this. And how do I know it's not solved? Well, I know it's not solved because my variable is not isolated on one side of the inequality. So in order for me to solve for x, I would need to move the 2. The 2 would move by adding. So x is greater than or equal to -5. So now my problem is solved, right? So if you didn't learn how to solve in the beginning of the chapter, you're just not going to do anything in this class. I'm going to just be honest with you. You have to be able to solve. You have to be able to simplify. So you have to make sure you know how to isolate a variable to one side. So x is greater than or equal to -5. My problem is finished here. So now all I have to do is what? Graph it and do the interval notation. So my graph comes straight from this solution. So 0, I'll mark my -5. X must be greater than or equal to. So greater than, shaded to the right, and it's a bracket on it. So the interval notation would be -5 to infinity. So we solved, we graphed, we did interval notation. And remember, the interval notation comes straight from your graph. All right, next we have x plus 4 is less than or equal to 1. So I'm solving for x. What does that mean? It means isolating it. So what would I do? I would need to move the 4. How would I move the 4? I would subtract it. So x is less than or equal to negative 3. Well, my problem is solved now because the variable is isolated on one side. So now I can graph less than, so we know it goes to the left, less than or equal to. So there's a bracket there. So the interval notation would be from negative infinity to negative 3 with a bracket. So you know how to solve. So you just get your equation, you isolate your variable by solving for it, right? And then you graph the solution and do your interval notation for the solution. So solving the inequalities is just like solving regular equations, right? Except that you have to graph and you have to do interval notation. Now, there is one special case where we're looking at our inequalities. So let's look at that. All right, so here we have 2x is less than negative 6. So we're trying to solve for x here. So in order for me to isolate x, I would need to move the 2. How would I move the 2? I would divide both sides by 2. So x is less than negative 3. So I graph my solution. So it's a parenthesis, it's less than, so it's going to the left. So the interval notation would be negative infinity to negative 3. Now, on this one, we have negative 3 times x is greater than or equal to 9. This is our special case here. Okay, this is our special case. So what does that mean? So let's look. I'm going to do a little special case here in the middle. So let's say we have an inequality statement that says 2 is less than 4. 2 is less than 4. That's true, right? Yes, that's true. So what if I divided or multiplied both sides by a negative value? So what if I multiplied negative 1 by 2, negative 1 by 4? So we would end up with a negative 2 and a negative 4. So the question is negative 2 still less than negative 4? So because it's a statement, so I have to do it on both sides. So I have a negative 2 being less than negative 4. Is that a true statement? No, that's not true. Negative 2 is actually what? Greater than negative 4. Right? Do we see that? So what happened here? Because when you do use your multiplication rules for equalities, whatever you do to one side, you must do to the other, and it should keep the truth value the same. Well, for inequalities, that is not the case. When you multiply or divide across the inequality symbol by a negative, it changes the truth value of the statement. It changes the truth value of the statement. So what is your rule? Your rule is multiplying or divide by a negative across the inequality flips the sign. So it flips the symbol. All right, it flips the symbol. So multiplying or dividing by a negative value, across the inequality symbol flips the symbol. So if you multiply or divide across the inequality, then you have to flip the inequality symbol. So let's look at our example that I have here. I have negative 3x is greater than or equal to 9. So we're trying to solve for x. Well, what's that mean? It means get x by itself. Well, how would I do that? I would divide both sides by what? By negative 3. So because I'm dividing by negative 3, this inequality symbol is going to flip direction. All right. So on the previous example, I didn't divide by a negative. The negative was already there. So I divided by a positive 2. If you divide by a negative, you must flip the inequality symbol. So this answer is x must be less than or equal to -3. So we get negative infinity to -3. All right. So that's your special case with inequalities. All of your steps are the same in the process of solving, except if you have to divide across the symbol by a negative. Okay. All right. So let's look at these two problems here. So we're solving the inequalities, and we're going to have to graph and then give the interval notation of the solution. So 3x minus 5 is greater than 2x minus 8. So I'm going to solve this how I would solve it. So you solve it how you would solve it, right? My process may be different from your process, but the steps really should be the same because we have to follow the same rules almost, right? But the order in which we choose to do it can vary. So I like to move my x's. You maybe like to move your numbers first, right? So maybe you did +5. So now I'm a +5 on both sides. So x is greater than -3. So this problem is finished. So we would just graph it. It's greater than, so that goes to the right. It's a parenthesis. So -3 to infinity. And we're done. So we have to make sure we can solve. Next, we have 7x plus 3 is less than 9x minus 3x. So I have like terms there, so I just combine those. So on this particular problem, I'm going to get my x's together. So I'm going to move the 7x to the 6x. So I'm going to get 3 is less than -1x. So then that means I'm going to have to divide both sides by a -1. So because I divide by a negative, what does it do? It flips my inequality symbol. So I have -3 is greater than x. But this is important. This is why I did this one. Because you are not graphing from the numbers point of view. You are graphing the solution, which is the x. So for me to say -3 is greater than x is going to make me think that I'm graphing a greater than. But I'm not. We are graphing the solution in terms of the x. So what you should do is you should read it from the variable perspective. X is what? Less than -3. So I'm going to rewrite it in the correct order, meaning I'm going to write it with my variable on the left side. So I rewrite it and it looks flipped, but it's really the same thing because the mouth is still open to the -3. See that? The mouth is still open to the -3. I'm just putting it in a way so that I can graph it and read it from left to right instead of reading it backwards. X is what? Less than -3 is the solution. So from -infinity to -3 would be the solution here. Okay. Now, it doesn't have to come out that way, right? It could come out a different way if you worked it different. I mean, the answer is going to come out the same, but it won't look like what happened when I did it because of the way I solved it. So let's do it again, but let's do it a different way because maybe we'll think about it differently, and let's see what happens. All right, so I'm up here. I'm at 7x plus 3 is less than 6x. So I'm going to move the 6x. So let's say you move the 6x. So now you're looking at a 0 on the other side. So now what? Well, now the 3 would move. So x is less than -3. Oh my goodness. Isn't it the same thing I already got? It sure is. Less than. So -infinity to -3. Okay, so it doesn't really matter, right? Solving is solving. The rules of solving don't change. The only thing that is additional now is if you divide by something negative, then you must flip the inequality symbol. And just remember that you're graphing the solution, which is what is the x. So you always have to read it from the variable perspective. So you always really want your variable to be on the left side. So even if it ends up on the right side somehow, just like the other problem I just did that we erased, we want to rewrite it. So if the variable is on the right side, we want to rewrite it so that the variable is on the left. All right. Okay, let's do some more. All right, so we have these two problems here. I would recommend that you try them yourself before you watch what I did, but it's totally your choice. So first thing here is I have a distribute because I have parentheses. All right, so for me personally, I like to get my x's together. So negative 2x minus 7 is less than 3. So now I'm going to move my 7. And now I still need to get x by itself. So I'm going to divide both sides by what? By negative 2. So x is what? So because I divided by negative 2, this is the biggest thing you're going to have to remember. What has to happen? My inequality symbol must flip the other direction. So it becomes x is greater than negative 5. So in my graph, it's a parenthesis greater than, so I know it's shaded to the right. So my interval notation would be from negative 5 to infinity. And I'm finished. Because the solution must be something that is greater than negative 5. Because dividing by the negative flips the inequality symbol. Okay? All right. Next one. Again, if you didn't do the first one, stop it now and do the second one and see how you do. That would be helpful. And then I'm pausing and see if you got it right. All right. So let's see. Negative 7x plus 4 is greater than 12 minus 3x. So again, for me, I like to get my variables together. I'm going to subtract 4 on both sides. So negative 4x is greater than 8. I'm going to divide both sides by negative 4. And what happens here? Well, because I divided by a negative, the inequality symbol flips the other way. So I get x is less than negative 2. So on my graph, less than goes to the left. So negative infinity to negative 2 with a parenthesis. Okay. So solving linear inequalities. Solving linear inequalities. You solve it, you graph it, you write the solution in interval notation. All right. So the second part of this section is 2.8 and 9.1, which is compound inequalities. So you have two types of compound inequalities. You have an and compound and you have an or compound. So the and compound is usually written as one problem. So it'll look like this. So if you read it from the variable, it says x is greater than or equal to 2. So it says x is greater than or equal to 2, which would go that way. And, so we know it's the word and because it's written as one big inequality. And x is less than or equal to 6. Less than. So you see what happens, just like in the statement, the solution is where? In between the values. The solution falls in between the values. So it's a compound because you're putting more than one inequality symbol present in the problem. So compound inequalities are going to have two inequality symbols in the problem. So an and inequality is just basically written like one big inequality problem. So here we graphed it. The solution is just going to lie in between them. And so the interval notation would be just like you read it from the other part. So from left to right, you're at a bracket at 2, and you go to 6 with a bracket. All right, so that's compound inequality. So it's given to you. So the compound inequalities are just like the regular inequalities, but you're going to have more than one inequality in the problem. So this was an inequality, an and compound inequality that was what? Solved already, right? Because we didn't have to do any work to isolate the variable x. However, we could be given one where there is work that needs to be done. So let's look at this one. 5 is less than x minus 6, which is less than 11. So what you want to do here is we're solving, right? And what does that mean to solve? It means we are trying to get the x by itself, get the x isolated. So in theory, it says one side. But one side, remember, this is like two separate inequalities being put together. So we really just want the x to be isolated in the middle. So if I want x isolated in the middle, remember, just like that one, you want the x for the and compound to be isolated in the middle. Who would need to relocate? The 6. So when you move the 6, you're going to have to move the 6 across both inequalities. So I plus the 6 to itself. I cross the first inequality. I cross the second inequality. So we're looking at 11 less than x less than 17. My variable is isolated in the middle. It's solved. This problem is complete. Now I just have to what? Graph it. So the graph would be x is greater than 11, x is less than 17. So for the and, the solution should always be between the values. And so the interval notation here would just be what? 11 to 17. Okay? So that's and. And then for the ors are so nice. It's going to have the word or written in between for you. X is less than or equal to -4, or x is greater than or equal to 1. So here, for the or compounds, the word or will be present. The word or will be present. So it's basically like you working two inequality problems, but on one graph. So these are solved already, right? And I know they're solved because the x's are isolated on each inequality. So I can graph this. So x is less than or equal to -4. So less than, and then the or equal to means a bracket. Or x is greater than or equal to 1. So greater than goes out to the right, and it's a bracket. All right. So the ors will usually go separate ways. So what's the takeaway here? The ands usually come together. The ors usually go apart in the solutions. So for our interval notation, remember we're reading what? Left to right. So we're looking at -infinity to -4 with a bracket. Then there's this gap in between. You're going to use what we call a union symbol. It's a union symbol. It's a U. It's uniting these two separate inequalities together. These two solutions are going to be brought together as one union. So -infinity, -4 union with 1 to infinity. And so that would be your solution there. So the ors, the solutions will go apart. The ands, the solutions should come together. Okay? All right, so let's look at one where we may actually have to do some work. All right, so here we have x plus 4 is less than 0 or 6x is greater than negative 12. So we actually have to do some work here because these are not solved yet. So we're going to solve them. So x plus 4 is less than 0. I'm going to subtract 4 from both sides. So I get x is less than negative 4. Then here I'm going to divide both sides by 6. My inequality does not flip. Why not? Because I didn't divide by something negative. The 12 was negative, but I didn't do nothing with 12. I'm dividing by the 6. So we have x is less than negative 4 or x is greater than negative 2. So what does that look like on the number line? All right, so negative 4, x is less than, so that's going to the left. Or x is greater than negative 2. That's going to the right. Well, that makes sense because my or should go separate directions. So my interval notation here would be what? We're going to read it from left to right. So it's going to be negative infinity to negative 4. Union with what? Negative 2 to infinity. All right. So your and your ors. So for your ands, you have one big compound with two inequalities in it. You just solve and try to isolate the x in the middle. And then the ors, the word or is going to be there. So you'll have like two separate inequalities to work, but they are graphed on the same graph. And then you do your interval notation, which should have the union between them. All right. So that's 2, 8, and 9, 1. Hopefully that was helpful.